Okay, good evening. Welcome to
MonsterMath77a.
MonsterMath77a. This is today we're going to talk about problem 19 from the 2011 AMC 10A. And it gave you a little bit of a problem today. It says in 1991 the population of a town was a perfect square. 10 years later, after an increase of 150 people, the population was 9 more than a perfect square. Now, in 2011, with an increase of another 150 people, the population is once again a perfect square. What is the approximate percent growth in the town's population during that 20-year period?
All right.
We'll talk about the choices later. So how do we approach this problem? This is a very challenging problem.
We have x squared, then you go to y squared plus 9, then you go to z squared.
Okay.
So, and you add 150 each time.
Okay. Good.
I mean, maybe you could like look for squares that are 300 apart.
All right. You could look for squares that are 300 apart.
Or or we could look like this. So you could see what number is plus 150 or 9 more than a perfect square.
Okay. That's a good idea too.
So it says, so a perfect square, you add 150 people, you get 9 more than another perfect square.
Yep.
Then you add another 150 people, you get a perfect square.
Yep.
I mean, I guess then maybe our best bet would be just looking around for perfect squares that are 300 apart.
Perfect squares that are 300 apart. Okay.
And I mean, maybe we could use the choices for that.
Well, the choices are about percent increases, so it's not going to be super easy to use the choices for that.
Well, how could we find squares that are 300 apart?
Yeah. What would you do to find squares that are 300 apart? That's a good question to ask.
So, I mean, I could look at squares that I already know are squares, and then maybe subtract 300 from them.
Yeah, that's just kind of guessing. That's not really using math. So what sort of math ideas could you use to find squares that are 300 apart?
I mean, so we have to change this into it. We need to make this sort of nice. So x squared plus 300 is z squared.
Yeah.
But I mean, what we want to do, it would be nice if we could change this into x plus something squared is z squared.
Yeah, that's a nice observation.
But I don't know that that's going to happen.
No, that's not going to happen, but there's a very similar idea to that.
I mean, you could use difference of squares. X squared minus z squared is 300. Or negative 300.
Yeah, so what's a better equation?
So, you could say...
How about z squared minus x squared? Z squared is bigger. Z squared minus x squared is 300. Okay.
So you have x, z minus x, and z plus x is 300.
Okay, great. So now we have found a way to do this with 300. The trouble here, so moving the 300 over the other side made it negative 300. Z squared is bigger. You may as well do it with positives, right?
Yeah.
Okay. The trouble is, solving this equation is going to be tricky because 300 has lots of factors. Okay? So try to apply this idea somewhere else in the problem. Same idea, but apply it in a different place in the problem.
I mean, maybe we could go from here to here.
Okay. So what is going from there to there? Say, whoops. My tripod didn't fall over.
So you have x squared plus 150 is y squared plus 9.
Okay, so what is this going to say?
So y squared's bigger again.
Yeah.
So you can see that y squared minus x squared is 141.
Okay, y squared minus x squared is 140. So we're going to go to the next movie now.